Welcome back, students. In the first part of light, here we are going to understand some of the basic things related to light. In this particular video, we will try to understand some of the basic questions related to light, as what is light, why light is a form of energy, how we get light, how materials are classified according to their behavior to light. So let's start. Light. How we can define light. So light is a form of energy that enables us to see. An object which gives out light is known as a source of light. Or in broader perspective, we can define light or the visible light is electromagnetic radiation within the portion of electromagnetic spectrum that can be perceived by the human eye. Now, more about electromagnetic spectrum you can understand with my another video named as spectrum. Light as a form of energy. Why we call light as a form of energy? Light contains photons, which are minute particles of energy. When an object's atom gets heated up, it results in production of photons. Now let's make this simple and understand it in this way. Light is a form of energy because we obtain light by converting some other form of energy, such as in sun. The chemical energy converts to light energy, as well as the candle. There also you can see the chemical energy been converted to light energy. Let's understand all about these things with an animated video.
Light is a strange thing. It isn't just what we can see. Light can be broken up into different types, and we call the whole family the electromagnetic spectrum. So even when it's dark, light is still all around us. Light can be created by making an electron oscillate. This creates an oscillating magnetic field and an oscillating electric field, which we call an electromagnetic wave or light. We often represent light as a wave. Just like water waves, light has a wavelength, a frequency, and a speed. The different colours of optical light have different wavelengths, and so does the rest of the electromagnetic spectrum. Gamma rays are the most energetic, whereas radio waves have the least energy. Even so, light is the fastest thing in the universe. In a vacuum, all light waves, even radio waves, travel at an incredible speed of 300 million meters per second. The Royal Observatory is overrun with squirrels. They're hard to miss during the day because they reflect visible light from the sun, but at night it's more difficult. However, they do emit infrared light, and if our eyes could detect it, we would be able to see them in the dark. If we pass high-energy X-rays through them, the squirrels look very different. Humankind has invented lots of different instruments to show us what our eyes can't see, like our Great Equatorial Telescope, which captures huge amounts of light and allows us to see objects that are tens of millions of trillions of kilometres away. We can see matter interact with light and change it. The gases in the Earth's atmosphere scatter blue wavelengths of sunlight, giving us blue skies during the day and red skies at sunrise and sunset. We can watch sunlight reflect off planets and the moon. During a lunar eclipse, red sunlight changes direction as it passes through the Earth's atmosphere and reaches the moon. And although visible light from stars can be absorbed by dust in space, we can detect the infrared light, which gets through to see baby stars hiding in nebulae. Light can even appear to stretch out. Since our universe is expanding and galaxies are moving away from each other, the light they emit is stretched to longer wavelengths. We call this redshift. Some galaxies are so far away that their light has shifted and stretched from visible to infrared, so we can no longer see them. Stranger still, the universe has unknown amounts of dark matter and bizarre black holes, so even if we can detect all the different types of light, there are still some things in the universe that will remain invisible to us.
After the animated video, I hope that you had understood what is light and why light is a form of energy. Now let's understand some of the properties and sources of light. Light travels with a very high speed. Light carries energy and information. Light travels in a straight line. Light can bounce back or bend when it comes in contact with different kind of objects. Light has color. Light has different intensities. Now, let's discuss about the sources of light. A body which produces its own light is called a luminous body, such as the stars and the sun. The sun is the primary source of light for the earth. A body that does not produce light of its own, but it just reflects back the light from some other source are known as non-luminous body, such as the moon and the planets. The moon reflects the sun's light. We can classify the sources of light in various forms, such as natural source of light and artificial sources of light, bioluminescence and hot and cold sources of light. Now, let's discuss about the rectilinear propagation of light. Rectilinear propagation says a light always travels in a straight line. Let's perform an experiment to understand this property.
Aim: to verify that light travels in a straight line. Apparatus: 3 cardboard pieces of same size on the stands and a candle. Procedure: make holes in the 3 cardboards at the center. Light the candle and fix it on a stand. Arrange the cardboards in front of the candle using a meter scale in a straight line. Move any one cardboard piece from its position slightly and again observe from the opposite side. Observation: when we observe the candle while the cardboard pieces are in straight line, we see the flame of the candle. When we move any one cardboard from its position, we do not see the flame. Conclusion: light travels in a straight line.
Now, let's understand the passage of light through a matter. Materials that allow light to pass through them are known as transparent materials, such as glass and air. Materials that allow light to pass through them but partially are called translucent materials, such as oil paper or the tracing paper. Materials that do not allow light rays to pass through them are known as opaque materials, such as wood or stone. When light rays used to hit any kind of opaque object, then shadows used to form, which we are going to understand in the second part.